Okay, Algebra 2, this is your review over polynomials. The first problem wants you to solve by long division. This is where you think back to when you were in elementary. And so you put what you're dividing by on the outside. So n plus 5 goes here. Your other problem, n squared plus 7n plus 10. Make sure you don't have any skips. What would you multiply n by to get n squared? You would multiply it by n. So n times n is n squared, n times 5 is 5n, so plus 5n. Draw a line, change your signs, and combine. 7 minus 5 is 2n, and these cancel. Bring down your plus 10. What would you multiply n by to get 2n? You would multiply it by a positive 2, so you say plus 2. And you get 2n plus 10. Draw a line. Change your signs and everything cancels, so your answer is simply n plus 2. If you are not sure if you got it right or not, you can always do synthetic division to check your work, but you have to actually use long division on this problem for the test. Number 2 is using your synthetic division. Remember when they give you a factor that you have to use the opposite sign, so instead of a positive 1 it's a negative 1. Remember, if you have any skips, you have to put zeros. So we have 3, 0 for m squared. No, m to the 4th. 0 for m to the 3rd, 0 for m squared, 1 for m, and negative 1 for the constant. Draw a line, bring your 3 down. Negative 1 times 3 is negative 3. Combine and you get negative 3. Multiply and you get 3. Combine and you get 3, multiply and it's negative 3, combine and you get negative 3, multiply and you get 3, combine and get 4, multiply and get negative 4, combine and get negative 5. So your answer is 3m to the 4th, because you're going to start one smaller than your degree, minus 3m to the 3rd plus 3m squared minus 3m plus 4, you have a remainder of negative 5. All right, number 3 wants you to state the degree and the leading coefficient of the polynomial. Your degree is going to be the largest exponent you ever have, so your degree is 3. Your leading coefficient is what's in front of the term that had a degree of 3, and so that is going to be 1/5. Okay, going to the next page. Number 4 wants you to describe the end behavior and also determine if it is an even or odd degree polynomial and state the number of real zeros. So first of all, the end behavior, it's going down at the beginning, so we're going to say down, and then it is going up at the end, so we'll say up there. Your degree is going to be odd because your two ends go different directions. The number of real zeros is going to be 1, 2, 3, 4, 5. Then they give us an equation. Your end behavior, if you're not sure what it is, you could always put it into y equal. So we have negative x rooftop 5 plus 4x rooftop 3. Zoom 6 to make sure you have a good graph. And your end behavior is going up at the left and it's going down at the right, so you're going to say up/down. The degree is going to be odd because one side's going up, the other's going down. And the number of real zeros, if you look at the graph on your calculator, there's 1, 2, 3. Number 5 wants you to determine the consecutive values between which real zeros exist and estimate the coordinates of any relative maximums and relative minimums. So you're going to put it in your calculator. Go to y equal. Clear it out. And you're going to have x rooftop 4 plus 4x rooftop 3 plus 6x squared plus 4x minus 3. You're going to your table for this, okay? First of all, you need to find where your zeros are. Okay, so look and see, do you have any zeros showing up? No, but you go from positive to negative. You go from negative to positive. So they are going to be between numbers. I go from positive to negative. You look at the y, but you use the numbers from the x. So between negative 3 and negative 2. And then we also go from negative to positive, so there's another one between 0 and 1. So then you're going to look for a relative max or a relative min. So we're getting smaller, we're getting smaller, we're getting smaller, we're getting smaller, we're getting bigger. So this is as low as it got. So you have a relative min at negative 1, it looks like. Min at negative 1. Okay, and then it gets bigger and bigger and bigger. It does not have a quote high point, so you would say none for relative max. Going to the next page. We want to solve the polynomial. So the first thing you do is you substitute a squared for t, or a squared for t. So this becomes a squared minus 21a plus 80 equals 0. Find the factors of 80. 1 and 80, 2 and 40, 4 and 10, 5 and 16, and that would be 8 and 10, which means that's actually 4 and 20, my bad. Signs are the same and they are all negative. And I need the factors that equal 21, which is going to be negative 5 and negative 16. So this is a minus 5 and a minus 16. So this is actually x squared minus 5 equal 0. X squared minus 16 equals 0. X squared is equal to 5. X is equal to plus or minus the square root of 5. X squared is equal to 16. X is equal to plus or minus 4. The 4 does not get a square root because it is the square root of 16. Number 7 wants you to use synthetic substitution to figure out if f negative 3 and f of 4, what their values would be. So you're going to use the actual number they gave you, so negative 3. You have a 1, a negative 3, a negative 1, and a 12. Bring down your 1. You get negative 3, negative 2, 6, 3, negative 9, negative 10, 30, and 42 is your answer. Then you do the same thing, but with 4. You have 1, 1, negative 3, negative 1, 12. Bring down your 1. You have 4, 5, 20. 20 minus 3 is 17. 4 times 17 is 68. 67. 4 times 67 is 268. So 280 is your answer. Number 8, given the polynomial and one of its factors, find the remaining one. So I would use synthetic division, and I would put a positive 3 out here. I have a 4, a negative 12, a negative 1, and a 3. Bring down your 4, and you get 12. This combines to 0. This will give you 0, negative 1, negative 3, 0. So then this becomes 4x squared minus 1 equals 0. So 4x squared is equal to 1, which means that x squared is equal to 1/4. And so x is equal to plus or minus the square root of 1/4. The square root of 1 is 1. The square root of 4 is 2. So plus or minus 1/2 is your answer. So they want all of the factors. Your factors are going to be 3, 1/2, and negative 1/2. Next page. Use the fundamental theorem to change the zero, or to find the zeros. Okay, you want to start off by changing. We don't want this problem. We're actually going to use 3x to the third minus 7x squared plus 4. So, stop and think about it. How many zeros should there be? And there ought to be 3 because of our degree. Let's put it into y equal 3x rooftop 3 minus 7x squared plus 4. Let's go to our table, and you could try 1 or 2, your choice. Let's go with 1. And so then we're going to have 3, negative 7. Don't forget your skip for x. Put a 0 there, and 4. So we bring this down. 3 times 1 is 3. This is negative 4, negative 4, negative 4, negative 4, and 0. So this gives me 3x squared minus 4x minus 4. You could use quadratic formula, or you could do 3 times 4 and see what you want to find the factors of. I'm going to go that route. 3 times 4 is 12. 1 and 12, 2 and 6, 3 and 4. Signs are different. Large is negative, has to equal negative 4. So that becomes 3x squared plus 2x minus 6x. Bring down your minus 4, cut it in half, pull an x out. 3x plus 2 minus, they both divide by 2, 3x plus 2. So you've got x minus 2, and you've got 3x plus 2. So this gives you x is equal to 2. This gives you 3x is equal to a negative 2, and so x is equal to a negative 2/3. So negative 2/3, 2, and 1 are going to be your zeros. Number 10 wants you to use Descartes' rule of signs to determine the possible number and if they are positive or negative. So the number that you will have is 3 because that is my degree. So how many sign changes do you have? You go from positive to negative, there's 1, back to positive is another, to negative is another. So you've got 3 sign changes. Always subtract 2 equals 1. Subtract 2 until you get to a negative number. So it's either 3 or 1 for your positive. Then for your negative, you're going to rewrite your equation, and anything that had an odd exponent changes the sign. So it's negative x to the third minus 3x squared minus 9x minus 7. If you look at that, there are 0 sign changes. 0 minus 2 is negative 2. So there are going to be 0 negative. So there are 3 zeros, and they are all 3. So you're going to have 3 positive zeros. Going down to number 11, list all of the possible rational zeros for each function. This is what we just did with our rational function, or rational zero function. You're going to list the factors for your constant. It's going to be 1 and 3. Your leading coefficient is going to be 1 and 6, 2 and 3. So then your P over Q can be plus or minus 1 over 1 is 1, plus or minus 1/6, plus or minus 1/2, plus or minus 1/3, plus or minus 3, plus or minus 3/6, which is 1/2, don't write it again, plus or minus 3/2, plus or minus 3 over 3, don't write it again. So that is your answer. Okay, looking at number 12, you're going to find all of the zeros. So the first thing you're going to do is find your possible rational zeros. So your constant, change colors here, I think. Your constant is negative 12. So the factors for that would be 1 and 12, 2 and 6, 3 and 4. Your leading coefficient is 2, so your factors are 1 and 2. So your possibilities are going to be a positive and negative 1, 1/2, 12, 12 over 2 is 6, 2, 2 over 2 is 1, I already wrote it down, 6, already written down, 6 over 2 is 3, 3, already written down, 3 over 2 is 1.5, 4, and 2, which is already written down. So these are your possibilities. You're going to use synthetic to test each of these possibilities. As soon as you find one that works, we're going to kind of quit using the original and go on to what you get with that one. So let's say we're going to try 1. Something you could do is go to y equal and put your original problem in, 2x to the 4th plus 7x to the 3rd minus 2x squared minus 19x minus 12. Okay, now this is not what it's designed for us to use, but just for the sake of time, you could go to your table here, and I know that negative 3 is going to work, and I know that negative 1 is going to work. So let's just start this with negative 1. And we're going to have 2, 7, negative 2, negative 19, negative 12. Bring down my 2. Negative 1 times 2 is negative 2. 7 minus 2 is 5. Negative 1 times 5 is negative 5. This would be a negative 7. Negative 1 times negative 7 is a positive 7. Negative 19 plus 7 is negative 12. Negative 1 times negative 12 is 12, which is 0. So yes, it worked. What you need to realize is you're now going to use this for your next round of synthetic division. Okay? So we know that negative 1 is, so we're going to try negative 3. So bring down your 2. Negative 3 times 2 is negative 6. 5 minus 6 is negative 1. Negative 3 times negative 1 is a positive 3. Negative 7 and 3 is a negative 4. Negative 3 times negative 4 is a positive 12, and they cancel and give you 0. So I know that negative 1 is a 0. I know that negative 3 is a 0. What you could do is try the others, or you could say, I now have a quadratic. This is like saying 2x squared minus x minus 4. And you could either factor it, if it worked, or you could use a quadratic formula. So if I use a quadratic formula, it becomes 1 plus or minus the square root of 1 squared minus 4 times a is 2 times b is negative 4. That's what should be right down there. All over 2 times 2. So it becomes 1 plus or minus the square root of, go to your home screen, and you have 1 squared minus 4 times 2 times negative 4. And you get 33. All over 2 times 2 is 4. So using your calculator, you would say 1 plus the square root of 33. Enter. Ooh, not that one. 1 plus the square root of 33. Enter. Divided by 4. And 1.68. And then you could say 1 minus the square root of 33 and divided by 4, and you would get negative 1.19. So you got a couple of ways you could do your answers. Okay, you know it's negative 1, you know it's negative 3, and then you would either say 1.68 and negative 1.19, or you could have said negative 1, negative 3, and 1 plus or minus the square root of 33 all over 4. Either way would work for giving your answer. We knew there had to be 4. We have 4. 2 of them were rational. So 2 of them came out of our possibilities. The other 2 are not rational, so they're not in that possibility. But you've got to get it to quadratic before you can use the quadratic formula. So you use the coefficients from the original problem in synthetic, then you use the coefficients you got for your second round of synthetic. Then you're at quadratic and you can use quadratic formula. All right, that's all the review. If you have questions before the test, come see me.